Hello everyone, welcome back to our channel. So yes, today I am going to discuss about the module 2, in which I will discuss the introduction to networking in Python. Yes, before that I have explained 4 module, right? In module 1 I have discussed the Python basic syntax and basics of Python. After that I have explained the operators, keywords, etc in Python. And after that I have explained the data structures in Python like list, tuples, dictionary, sets, and in module 4 I have explained the file handling. And this is module 5, in which I will explain the introduction to networking in Python, right? So whatever I have started a series of Python, it would be very beneficial to you guys. I hope you are enjoying this session of you are enjoying this series of Python with me, right? So let's start without getting delay. So first of all, you have to understand what is networking, right? Networking and sockets. First topic is, as you can see over the screen, guys, please follow my cursor because you will get to know that where I am. So yes, first is introduction to networking and socket. Firstly, you have to understand what is networking, right? So basic definition of networking is the process of connecting two or more computing devices together to share resources, right? Data or services. I'm repeating again. Networking is the process of connecting two or more computing devices together to share resources, data or services. And more than that, it allows communication between devices over local or wide area networks. If we talk about the example of networking, then when you visit a website or send an email, right, your device is connecting over a network like the internet to reach a server. In essence, networking forms the backbone of the internet. The communication between devices happens via protocols, right, like TCP and IP. Protocols like TCP and IP, which defines the rule for data exchange. So this is all about the networking. Basically, networking is a process in which connecting of two or more computing devices together to share resources, data or services. So basically, networking allows communication between devices over the local or wide area network, right? And whatever I have given you the example, it would be very understandable to you because it was very in simple language, right? Now it's time to describe what is socket. Yeah. More than that, what I have explained right now, I think I have explained what is networking, right? Networking. Now I am going to explain what is socket, right? So please, socket, sorry, yes, right? So yes, be careful and be attentive, right? So yeah, socket acts like a virtual endpoint for sending or receiving data. Just like a plug fits into a socket in your wall to get electricity in programming, a socket connects your application to the network, right? A very basic example that I have given you, just like plug fits into a socket in your wall to get electricity, just like in programming, a socket connects your application to the network. It is very simple. It is the interface between your application and the underlying transport protocols. And protocols is TCP, UDP, etc. So yes, using sockets you can establish communication between a client and a server. Think of it as the telephone jack in the wall that lets you talk to someone on another phone, right? So yeah, I think socket is clear to you. Socket is a virtual endpoint for sending or receiving data first. And this example is like when you just plug fits into the socket into your wall to get electricity. Socket is something like that in programming. Socket connects your application to the network, right? And using socket you can establish communication between a client and a server. Okay, now it's time to explain client versus socket. Yeah, what is client versus socket? Sorry, client versus server. So actually, yeah, it's time to discuss client versus server. So in client, what is client, right? Client initiates a connection to the server. It is like the person who makes a phone call, okay? And server listens for incoming connections. It is always available and waiting, just like a helpline number. And once a connection is established, both can send and receive data. That's all about client and server. And now it's time to explain IP address and port. Yes, IP address and port is what yeah, sorry, yeah. Okay, and port, right? So what is IP address? Basically, IP address is a unique address for each device on the network, like a home address. I can give you example of IP address like 192.168.0.5. Actually, you can see here. What is this? 192.168, right? 0.5. This would be IP address. This is for only example, not it is serious, not it is IP address of anything. It is just for example. You have to understand something that is written in this way. It is IP address. Okay. Now what is port number? Yeah, a virtual channel for communication is a port number. Each service uses a specific port, like HTTP uses port 80, HTTPS uses port 443. Okay. Yeah, I'm giving the example how you can see what is port. Like port is written like port 80. This is the port number of HTTP. Okay, so together IP plus port define a socket endpoint. Yeah, IP and if the combination of IP and port, it define a socket endpoint, right? Now I will explain the types of socket, right? So you have to understand how many types of socket. Firstly, how many types of socket you have to understand it, right? So first, TCP is sock stream. Yeah, first is TCP sock stream. Connection, it is connection oriented. It ensures reliable ordered delivery of data. And if we talk about the example of TCP, then web browsing. HTTP is the example of TCP. Email is also example of TCP, right? And if we talk about the UDP, because there are two types of socket that is given here. So yeah, there are two types of sockets given here, TCP and UDP. So basically TCP is what? Yeah, TCP is a connection oriented. It ensures reliable ordered delivery of data. An example of TCP is web browsing, HTTP, email, etc. And now if we talk about the UDP is sock DRAM. Okay, so it is a code, and yeah, it is connectionless. UDP is connectionless. It is faster but less reliable. It is used for live streaming and online gaming, right? There are very different TCP and very much difference between TCP and UDP. TCP is connection oriented, UDP is connectionless. TCP ensure reliable ordered delivery of data, but UDP faster but less reliable. Okay, and if we talk about the example, then TCP is used for email, web browsing, etc. But UDP is used for live streaming and online gaming. Now it's time to explain Python socket module. Yes, Python provides the socket module for low-level networking interfaces. It is a powerful tool to build both client and server applications. Let's now dive into a live demo. Okay, and I will walk you through each line. So first, you have to understand. Yeah. So you have to write a code like exploring the socket module, and for that you have to go for any interface. Like I'm using Jupyter Notebook here, so we can see what with the code of us exploring the socket module. Yeah, first of all, simple. When you are using the socket module, then you have to import the socket, and just for checking, this is the code. You can also copy, you can also just take the reference from here, and you can write this code in your system, and then you can see the output, right? So import socket dir directory check. Okay, socket. So I have checked the directory, and as you can see the output. After that, this is for TCP socket.sock stream, and this is for UDP socket.sock dgram. When you run this code, import socket, then you get the output of this code. When you will not just run the code of import socket, then you will not get the output of this socket.sock stream and socket.sock dgram. So yeah, it has given whatever the result is socket dgram is 2. Okay, now the third is exploding the socket module. Yeah, so when we go for exploding the socket module, firstly we have to import and explode the socket. So as I told you, import socket is here, then print dir socket, it is for only directly, not for any thing, and then create a TCP client socket. Okay, so what you will write for TCP client socket, you will write TCP for TCP client socket equal to client socket equal to socket dot socket and in parenthesis you can see the code FINET and socket sock dot stream. So basically import socket is what? This load the socket module which contain all the classes, constant and function for networking. And dir, yeah, dir socket list all the available methods, classes and constant inside the socket modules. After that you can observe two or more two or more unfamiliar words like FINET and sock stream. What is this? I'm just explaining. This is FINET is address family IPv4 example. If we talk about the example, then you can get the output like IPv4. And what is sock stream? Sock stream is used for TCP. After that you can observe that sock dgram, it is used for TCP, UDP. Okay, and socket, yeah, we have used socket here, like many times we have used socket. So in socket and parenthesis, it is a main function to create a socket. And when we talk about the Jethoyname and Jetho, what it is written over here, yeah, Jethoyname and Jetho's name. So yeah, it is something like that. Now create a TCP client socket. Okay, this was whatever I was telling you, that was this code. This is simple TCP server in Python. So firstly you have to import the socket. After that you can create a socket by using this code. Then you can bind the socket to IP and port by this code. Okay, and then you can start listening for connections by using this code. And then you can accept a client connection by this code. And then you can receive data from client. Then you can use this code. And when you want to send response to client, then you can use this code. Response equal to hello from server and con.send respond itna. And then when you want to close the connection, then you have to write con.close. And by using these codes you can just create a TCP server in Python. Okay, simple TCP server in Python. Yeah, here it is something like written like connect. So what means that connect method is used by client to initiate a connection. Example.com is also written here. So it is a server's domain name. You could use an IP like whatever I have given you example of IP, and it is the port number for HTTP. And behind the scenes this does this does a DNS lookup, find the IP and open a connection. Okay, and it is something like that, HTTP etc. And we are crafting a basic HTTP get request to fetch the home page, like. And what is the meaning of /r and /n? Means carries return a new line used to end lines in HTTP. And dot encode converts the string into bytes, because socket send and receive byte data only. Okay, so yeah, basically it has client socket. Here you can see client socket dot send whatever it is. So we are crafting a business, it is something like that, that is related to HTTP. And then you just yes, receive response means what? Receive response is like receive 4096 reduce the to 4096 bytes from the socket. And dot decode means dot decode convert the received byte data into readable string. So you will see the HTML example of example.com printed into your terminal, and then you have to close the connection, because always close your socket when you are done to free up resources. Okay, then you get the output like this. Okay, firstly this is off directly. After that, from here you are just getting the yes, you're just getting the output of this code, client socket etc, whatever it is. Okay guys, so yes, from here we have what we have discussed. We have discussed what networking and sockets are, what is the difference between TCP and UDP sockets, and how a client connects to a server using IP and port, and how to use Python socket module to send an HTTP request. Alright guys, you have just copy this code. You can take the reference of this code. You can take the reference of this code, and then you can just send the request to HTTP. Okay, it is used to Python. It is just like how you can use Python socket module to send an HTTP request by using this code. Import socket, print etc, and whatever it is written over here. Just follow my cursor guys. Now it's time to discuss the second topic, that is understanding client server architecture. So first topic is request response model. What is this? Firstly, at the heart of client server architecture lies the request response model. It is a communication pattern where the client initiates the conversation by sending a request, and the server listens for incoming requests, processes them, and sends back a response. This model is synchronous and predictable, making it a backbone of web communication. For example, when you type a URL and hit enter, your browser client sent a request to a web server, right? And the server processes the request, like fetches data, perform logic, whatever it is, and it sends back a response like an HTML page. Okay, and the browser renders the content. So this interaction is a basis of almost all internet communications, from browsing to messaging apps. Okay, now it's time to explain the second topic, that is one-to-one and one-to-many communications. Yeah, one-to-one communication is a direct connection between a single client and single server. For example, you log in into your bank account online. This is one-to-one communication. But when we talk about one-to-many communication, then one-to-many communication is a single server handles multiple clients simultaneously. This is more common in real-world applications. Like for example, a web server handles thousands of users at once. A WhatsApp server handles billions of messages from millions of clients daily, right? So this is the example of one-to-many communications. So it serves typically using multi-threading or acronymous I/O input-output to manage many clients at the same time without blocking, right? If we talk about the real-life example of one-to-many communication, then WhatsApp is first example. Client is like mobile app, server WhatsApp cloud infrastructure, request sending a message, response message delivery confirmation. Web browser, yes, client is Chrome, Firefox, etc. Server any website's backend like google.com, request fetching a page, and response HTML, CSS, JavaScript files, etc. FTP, file transfer protocol. So yeah, client is FileZilla, server is FTP, file server, request, upload, download files, whatever it is, and response success and failure messages. So this example help make us concept relatable for non-technical and technical audience. So now I will explain the code that is for simple TCP server in Python. Okay, so let's go to the Anaconda Jupyter Notebook. So this is something that is simple TCP server in Python. So yeah, this is the code that you can take reference from here, and you can write the code into your system, and then you can see the output, like import socket, whatever. So firstly you have to import the socket when you are using the socket module, and then you have to create a socket. So for creating a socket, you can write server.socket, and then you can create a socket inside it. So there are two types of socket, as I told you. So this is the example of socket. Stream is the socket like TCP. Okay, so firstly you have to create a socket, and then you bind the socket to IP and port, and then you can start listening for connections, and then you can accept a client connections. right? And then you can receive data from clients, and from receiving data from clients you can use this code like data equal to con dot receive and I024, and after that print data whatever it is, and then you can send the response to clients, and for responding the clients you can use this code, and then you can close the connections, because close the connections is very important when you end up your program. Okay, so for using the for closing the connection you can use this code con.close. Okay, and so yeah, socket is what, create a TCP socket, and the example like IP v4. Okay, and then bind localhost 12345 whatever it is. So yeah, attach the socket to the local address and port. Dot listen is what, server is ready to accept one connection for now. Dot accept is what, wait for client to connects, return the connection and address. Dot receive, like here you have written dot receive 1024. So yeah, it reads 1024, it means that 1024 bytes of data sent by the client. And then you can see one thing, that dot send. Yeah, what is meaning of dot send? So send back a response. And dot close, yeah, dot close is used here because close the client connection after finishing the response. And this is simple code that I have written over here for simple TCP client. So yeah, for TCP client you can you can use this code. You can take the reference of this code, like you have to firstly you have to import the socket, and then you can create a socket like client socket whatever it is, message, and then data, and then you can close the client socket, because you have now you have finished your work. Okay, so yeah, first run the server. Yeah, you have to run the server first and then run the client in the separate terminal. So from here what you have what you got understand and what you understood right now. Yeah, you have introduced actually you yes, you have understood the client server architecture using the request response model, then demonstrated one-to-one and one-to-many communication connections. Yeah, then I have provided you real world relatable examples like WhatsApp, Wave, FTP, and then I have explained a live TCP client server communication with full code and diagram. Right, guys? Yeah, so now start the third topic, that is hands on creating a simple server. Right? Firstly, when we talk about creating a server, we are building a program that listens for incoming connection from clients, and it processes the data sent by them and optionally sends data back. So the most common way to do this in function is by using the socket module, right, which give us the access to low level networking functions. A server essentially plays the host role in the client server architecture. It is always ready to serve whenever a client knocks, and the very first step in building a server is to create the socket. Yeah, I have always given the example. Whenever I have written a code, I have firstly just create a firstly I have import the socket, and then after I have create a socket. So yeah, the very first step in building a server is to create a socket, which acts like a phone line between the client and server. We use socket.socket function for this, and it requires two arguments. First, AFINET. This means we are using an IP before address like 127.0.001, and socket stream. This tells Python we want a TCP connection, like reliable connection based. After creating the socket, the server needs to bind itself to a particular IP address and port number. Think of it like setting an address and door number for your office so clients know where to visit. We do this using .bind method here. Usually for testing we use localhost and any available port like 12345 just for example. After binding we use .listen to start waiting for incoming connections, and this does not accept a connection yet. It just tells the operating system I am ready to accept the connections. So yes, once a client tries to connect, the server uses a .accept to actually establish the connection, and this functions wait. What waits? It means block until a client connects, and then it returns a new socket object for communicating with that specific client and the client's address. From here the server can receive data using .receive and send response using .send function, and these methods allow two-way communication between client and server, just like chatting over a messaging app. So yeah, I can give you the I hope this is clear to you guys. Now I can give you the code. By clicking the reference of that code, you can use the code, and then you can find the output, and then you get to know how you can use socket module to TCP server code. Okay, to TCP server. So firstly, I'm just taking you here, Jupyter notebook. So as you can see that what is this? TCP server code. Oh, this is TCP. No, yeah. So yeah, this is the example of TCP server code, as you can see over here. Like server.socket, yeah, server.socket and whatever. So firstly you have create a socket, right? Then you bind to IP address and port, then you start listening, and then you accept a connection, and then you receive the data, right? And then you send the response, and then you close the connection. So yeah, why we create a socket? To allow communication using a standard protocol like TCP. Why we bind? To define the address like IP and port where the server will accept connections. And why we listen? To notify the system that we are ready for clients. And why accept? To actually create a connection with a client when one appears. And why we receive and send? To handle the data ping transport. Okay, so yes, the output would be like that. Server is listening on port 12345, and after that connected to client at ITA, and client says hello server. That's all. You will get the output here, hello server, and whatever it is written over here, hello from server, hello server. What is? Yeah. This is something like that. Now moving to the fourth topic, that is hands on creating a simple client. So yeah, in any client server model, the clients plays the role of the initiator, right? It reaches out to the server, establish a connection, send a request, and wait for a response. In our case, the client will connect to a server running locally on the same machine and send a message. Just like the server, the client also uses Python socket module to manage the interaction. The very first step for the client is also create a socket, as I have discussed already many times, using the socket.socket function, and the parameter like f, net, and socket stream is also used here, are the same as used in the server, because the client and server must agree on the type of communication. Okay, and once the socket is created, the client will connect to the server's IP and port using .connect IP port, and if the server is one of this is on the same system localhost or whatever it like 127.0.01 can be used. So yes, after connecting, the client can send the message to the server using .send function or send dal function. We generally encode the message using .encode function, because the socket sends bytes, not plain text, and once the server receives and process this message, it might send a response back, which the client will read using .receive, and this completes the basic request response cycle, right? Finally, the client should always close the connection using .close function to free up the system resources and properly terminate the connection. Forgetting to close socket can lead to problems like connections limit being reached or unexpected behavior in larger applications. So this is why cleanup is best practices in all network programs. So this is how a real-time chat or browser server communication works behind the scenes. While we are running, we are using simple command line programs now. So same logic applies to large scale system like WhatsApp, Facebook, or even banking apps. So yeah, now we are just moving to the client code like TCP client. So yeah, moving to the Jupyter notebook. Firstly, you have to, this is something TCP client. Okay, this is something that TCP server. Okay, this is something for TCP client. So this is for firstly you have to create a socket, right? And whatever yeah, you are creating the socket like client.socket, and you are just writing the thing here, AFINT, two basic thing that I have discussed. Then you can connect the server, like you are just sending the message hello server, right? Connect the server, client socket, whatever it is, and yeah, print now you can send the message to the server like hello server encoded, whatever, and then you can receive the response from server, like data whatever it is. Okay, and then you can close the connection. That's all. Firstly, you have to do import the Python socket library required to create and manage network communications, and always at the beginning of your socket program, right? So yeah, this is all clear to you. Send a message to server, encode, convert the string into bytes, etc. So in last, that socket client socket dot close, right? So client socket dot close is what? Client socket dot close, you can see right here. So what does it mean? It means that close the connection. Always do this, clean up the connection, to clean up the connection and avoid the resource leaks. Okay, so this is all about happen. First code was related to exploring the socket module, right? So for exploring the socket module, firstly you have to import the socket, then you can create the socket, and then you can connect to a server, then you can send an HTTP GET request, and then you can receive the response, and then you can a response client socket, whatever it is written over here. I think it is not right thing. And then you can close the connection, right? So you get this type of input output. Then the second code is related to TCP server in Python, how you are using the socket module in TCP server in Python. Okay, and then the third code is TCP client. Yeah, so this is for server and this is for client. So how you can use the socket module in TCP client in Python. Okay, and the last code is related to the last code would be related to all together, like how server and client, we are just putting the server and client together, and just we are getting the code here. So firstly I will explain the topic and then explain the code. Okay, now the last topic is putting it all together. So yeah, running both script and observing how data flows, role of IP, port and encoding, error handling tips, and common issues like port already in use and connection refuse. So yeah, now we will understand. Now that we have created created both a server and a client, it's time to run them together. Yeah, I have given you the example that we have created this server and we have created clients in separate way. Now it's time to run them together and observe the full data flow when both scripts run, preferably in two separate terminals. You can see how the client connects, send data, and how the server receives it, processes it, and replies. Okay, this is the actual working of request response cycle, and which powers everything from web browser to chat apps. The server script must always be started before the client script, and this is because the server needs to start listening and waiting for a connection. If the client is started before the server, you will likely get a connection refused, like error, because there is no one to accept the connection yet. Once the server is ready, the client can connect using the same IP address and port number and that the server is bound to. This is how the two identify each other on the network. When the client sends data, it must be encoded, and the server will receive the encoded data in bytes. Okay, and the server then decodes it and respond with another messages that also needs to be encoded before sending and decoded on the client side. This highlights the importance of dot encode and dot decode in ensuring text-based communication through sockets. So yeah, you should also explain the role of IP and port number. First, the IP address identifies the machine, and port number identifies the specific application like server running on that machine. So yeah, port 80 HTTP is on 443. So in our example, we used port 12345. But if another application is already using it, you will get a port already in use error. Okay, so in that case, using either close the running application or change the port. Another common issue is forgetting to close the socket after communication. It would be a big issue, so always close the socket. If the socket is not properly closed, it might stay active in the background, so yeah, leading to binding errors. Also, always wrap your code in text try except blocks to gracefully handle unexpected errors like connections reset, timeout, or broken pipes, etc. Okay, so firstly, you have, when you want to put these two together, so you have to write the code. So yeah, I will show you the example, and I will show you the code for full working server code. So with error handling, this code would be related to with error handling. You have to understand it first, then I will explain without error handling. So it is related to with error handling. Yeah, full working server code with error handling. So yeah, firstly you have to import the socket, then with error handling you can use the try except block. I have already no, I have not explained error handling right now yet. So yeah, firstly you have to import, when we understand this code, firstly we have imported the socket already, then we are using the try except blocks. So in try block server socket, we have created the socket, okay, and then print this server is listening on port 12345, and then we are just accepting this, and then we are just receiving, this code is for receiving, and then this code for responding, and after that server socket close. Yeah, server socket close is related to what? Server socket code is related to close the connection right now, because now work has finished. And then try except block is here. So yes, except try block has end and except block has started from here. So I try except exception has E and print error E. Okay, now I will explain the next code, that is for with error handling. Full working, yeah, it is with error handling and it is also with error handling. 1 second. Yeah, full working client mode. Yeah, this is full working server code, and this is full working client code with error handling. Okay, so firstly we have created an import socket, and then we are using here socket try and accept what blocks. Okay, so in try block, what we have created a socket first, and then we are just give a message to the user that connected to server, then we have sent a respond, and after that we have closed it, and then try block has ended, and now except block has started from here. So yeah, accept exception as E and print error E. So it is all about full working client code and full working server code with error handling. Okay, because error handling is important here. And why we have used try except block? This help capture and print errors like connection refused, port already in use, etc., without crashing the program. And why we are using the closing sockets? Yeah, we make sure con.close and server socket close function are called to free up the ports using localhost. Yeah, we are using localhost here also, so it is ideal for testing locally for real use and real use, and replace with IP to the server machines. Okay, and when you run this, then you will get the output. So yeah, full working server code, you will get the output like server is listening on port 12345, because you have print here, so it will display on a screen as output. And then connections, yeah, connected to client, like it will print at a screen, you will get the address like 127.0.1 and 15 whatever it is, and then the client says, yeah, client says is what? Hello server. You will get this type of message. And accepted output like client terminal. So yeah, this is for client terminal. Firstly we have just imported the socket, and then we have in try block we have just created socket, and then it will you will get the output like connected to server. Okay, and then you will get the output server says, and then you can get the output like I got a message. Okay, so this is all about for today's session. I have discussed all these things with very honesty and with full of sense. So I hope this is clear to you guys. If you have any doubt and if you want something from me, then you can do comment in comment box. I will always create the video in a way that you want, and I will always provide the study material if you will tell me. And if you need the code, like if you need this file, Jupyter notebook files, then I will also share, but you firstly you have to do comment in comment box, then I will share to you guys. whenever you will watch this video, you can do comment whatever you get problem, you got stuck wherever, you can do, you can contact me anywhere. And for more, you can join my Instagram account and WhatsApp, join my WhatsApp group also, where you can get extra informations about the Python and other technical and financial subjects, because I'm a technical educator as well as financial educator. So yeah, finance educator. So yeah, you will get all these things. And if you found any error, then you can also suggest me to improve that, right? So if you need any improvement, you can do comment. If you need any special assistance, like in the field of Python, regarding Python and like technical subjects and regarding the finance, you can communicate, you can communicate in WhatsApp group, and you can visit on my Instagram page like fintech learn, where you can direct DM me. So yeah, you can get the access by these ways to me. And that's all for today. I hope this is clear to you guys. Bye bye, take care.